Okay, good morning, good afternoon, good evening, wherever you might be. By my clock, it's time to start. So the first thing we have to do is share the agenda. Uh, Chris, could you advance the slide?
Yeah, 1 second.
Okay, so here's the note. Remember everybody, these are the uh, responsibilities for IETF participants to make sure that we're all playing on a level playing field. Next slide. And please be respectful at all times. And remember that we're all here to improve routing security, and please work together. Next slide. For the virtual meeting, just remind folks that we're when you're not speaking, turn your video and audio off or mute them. And if you have a headset, it seems to help. And the next slide is the draft agenda that was sent out yesterday, which was basically to continue doing the things that we didn't get finished at the last meetings because the agenda was too tight. So we know people want to speak to these three drafts, and if there's any other time after that, we can speak to other drafts when we're done with those. Is there any agenda bashing? Okay.
Um,
Go ahead, Kier.
yep. The only thing I will add here is, Russ, that on the last draft, since we are expediting it, we just wanted to get the working group feedback and see if they have any concerns.
Okay, thank you. I got a note earlier from Sriram that he wanted to speak to verification. Um, did this? I just got some slides, and so I will upload them while we're talking about the first one. Job, did you want to start with your slides or Rudiger's slides? Which one of you guys who's provided slides want to go first, Job or Rudiger?
Looks like Job is trying to get his slides sorted out.
Well, I posted them already, so you should just be able to pull them down.
Think, yeah.
Can you hear me?
Yes, I can now.
Nice. Let me see. Yeah, sorry, the data tracker was super slow, so it took me like multiple minutes to get into this meeting. Maybe other people were stuck as well.
Okay, well, we're going to start with your slides then.
I would say start with Rudiger. He was first to submit, and it's
Okay.
his slides. So I figured I'd just do him a favor by uploading it into the system.
Okay, Chris, can you pull up Rudiger's slides?
So let me see. So does anybody hear me?
Yes.
Okay. So next slide. As you might have seen on the first slide, that is actually something that I mentioned that in an email a couple of hours ago, done at the end of the Prague meeting, and since I only received the call for this draft this very morning, on this side of the time zone range. I did not get to quickly do a little bit more of what I have been looking at. In Prague, the students of Matthias Wälisch asked me some questions about the verification draft, and that made me look into it and detect a lot of nasty thing, beginning with that I had not looked into it for a couple of years. So looking closer into it, I found a lot of things that I think actually need some work. Simple things would be just terminology, like, well, okay, the draft title is talking, oops, let me see. Yes, draft title says verification, but when you look into the draft, you find that it actually maps in the decision algorithm into the domain of the set of valid, invalid. And in fact, I think validation would be the correct thing to call this, because verification should be reserved for BGPsec, where we unfortunately failed to name the classification of verification. But well, okay, verification is something telling the truth, and the BGPsec is telling whether the path is figured out to be true, while the ASPA-based thing is actually validating the path under certain criteria. Looking into the text, there is actually quite some stuff that is fairly badly structured, like duplicate text or topics in very distant parts of a draft, and actually going very closely through the draft and trying to figure out which audience is actually addressed by the various parts of the draft, and grouping stuff so that the topics come up with the different audiences in mind would make a lot of sense. The security considerations section looked quite lacking to me. It starts with very broad benefit claims, and I think it looks very much like hand waving. And then it goes into very technical discussions where I feel that kind of detail seems kind of a little bit interesting, because it is not really clear how complete the explained set of vulnerabilities is. In Prague, I did this one pager with this note that I wanted to be short, and kind of the thing that I was trying to skip in the very short thing is essentially what I called in my mail the elephant, and that is the question about AFI agnostic or AFI differentiated, and well, in case of AFI agnostic, whether the explanations in this draft are actually sufficient to explain the necessary the relevant implications to, in particular, the operator. And of course, if such basic structural things are being questioned, one would not be surprised if some rework may be necessary as consequence of what rework of other related drafts may be required if there are actually substantial consequences to the questions that I ran into, and actually the remark of apologies to the implementers, I got the comment from one of the draft authors that he was saying apologies to the premature implementers. So let me have well, okay. I can run through some of the more detailed notes and questions I have. It's not really that well structured, else I would have submitted slides. But if there are questions or comments right now, I would stop for that.
I have a comment. Job Snyder's Fastly
Sure.
Open BGPD RPKI client Open BSD. As to API specific or API agnostic, it is good to remind this group that there is a spectrum of granularity. We can make mechanisms that are specific to a prefix, specific to a BGP session, specific to a API, and specific to AS arcs. And in June 2023, the working group came to consensus that API agnostic was to be the minimum viable product. We saw benefits in the realm of the BGP implementations, where it was easier to achieve good performance using an API agnostic approach. But more importantly, we saw benefits for operators, because by removing buttons, we make it harder to misconfigure ASPA. And indeed, it is not as granular as it could be if we included the API, or if we included something specific to BGP sessions, or even included something specific to individual prefixes. So it is a trade-off choice. Now, currently, RPKI client, Routinator, Fort, RPKI Prover, Krill, RIPE NCC's test bed, Ben Madison's RPKI Mincer, Tom Harrison's ASPA demo, all are API agnostic. And I fear that this is a choice we are going to live with, because I don't think we're going to go back, because none of the argumentation offered so far to make it API specific outweighs the benefits that we perceive from API agnostic. Now, as to your other comments about the structure of the text, I think it would be very good to take a look at that and make the document as readable as possible. And in that regard, I think help is very welcome.
Okay. Kind of my simple-minded understanding of a reasonable choice for actually being doing AFI specific ASPAs would be just at the AS level. And well, if the community thinks that the argument we are not expecting, like as it is documented, we are not expecting major differences, thinks that this is a prediction that is valid and will be valid for the lifetime of the protocol, well, okay. However, the explanation and the guidelines that I would be looking for as an operator I was in the text is telling somewhere, well, in the 9.2 chapter, ASPA issuers should be aware of the implications, and somewhere network operators must keep their ASPA correct. So kind of the interesting question is, does the draft as it stands explain what incongruent AS topologies would mean for the operator to deal with? And as there is this, well, okay, actually both statements should be aware of the implications sounds very much like a truism, general, very general truism, and must keep correct also sounds very much like coming from that chapter, but the question for me comes up, do I get an explanation what the consequences of having incongruent AS topologies with ASPA will be?
If I may interject, Rüdiger, I agree with you that the sentence you cite with the truisms is not optimal. It's true because it's true, and you must do it correctly. What I'm happy to take on with the other co-authors is either removing that sentence or making it useful, and perhaps we can add an appendix that enumerates through a few examples of potential incongruence and the effects that ASPA validation would have or would not have. Because in my mind, the approach of making it API agnostic means that in a few corner cases, you do not get to enjoy the benefits of ASPA protection, like when you buy transit from somebody, but also have them as a peering partner, a settlement-free port situation. And I think it could be valuable to be more explicit, like this is the scenario where ASPA helps you, and these are scenarios that are essentially out of scope for ASPA protection. So that's one to-do item noted.
think Sriram's been waiting in the queue as well. And now Randy.
Go ahead, Sriram, then Randy.
Maybe Sriram's mic is not working. Skip on to Randy and come back to Sriram.
Good morning and various other times. Given that 1/3 of V6 enabled ASs do not have the same neighbor set in V6 as they do in V4, I think the discussion of the implications belongs in the security considerations section.
Okay.
Go ahead, Keir, then Oliver.
Can you hear me? This is Sriram. Can you hear me?
Yes, we can hear you now.
Okay, thank you. So Rudiger, regarding validation versus verification terminology, in different drafts, like ASPA, SPL, we are saying that validation pertains to X.509 validation. And verification is something that we are using with regard to using the validated ASPA or ROA objects and making use of them in the form like a whitelist. What are the ASS that can legitimately announce a prefix? What are the ASS that are providers? So when we make use of that kind of whitelist for the path verification, we are using the term verification. So just wanted to mention that. I don't know if you want to agree with that or we need further discussion. If I may continue, the other comment I have for Rudiger is that the security consideration section, Rudiger, you and I met in Prague. We met in a group with Matthias, Tresilo, and others. Had a long meeting there in the evening. You and I spoke specifically about security consideration section. So what we have done in the update that we have done on GitHub for the draft, I will speak about it soon in the next talk, but just want to mention that your concern was taken into consideration, and we have included other shortcomings of the ASPA with regard to path manipulations, where it is not able to detect them. So you'll be able to see that soon. But I'm also going to talk about that in the next, in the talk that follows.
Okay, go ahead, Keir, and then Oliver.
Okay, can you hear me?
Yeah.
Super. One comment that and Keir Patel speaking as a working group member, not as a working group chair. One comment I have had, and I made this also a few years back when we decided to remove AFI out and make it AFI agnostic. Since the point was brought up, I think the comment that I want to make is anytime you take AFI out of BGP, it's quite dangerous. You don't know what you're dealing with. With new SAFIs coming up or new AFI SAFIs coming up like Rift and LSVR soon, you are going to have a number of mechanisms through which you are going to distribute IP routes and connectivity. That coupled with how the cloud is manifesting itself and the peerings that are happening in the cloud, at least we should have, as you suggested, Job, some sort of an appendix that talks about how the peering has been thought through in the appendix section from an AFI agnostic viewpoint, and then we can attack should we figure out a need for AFI in future. Thank you.
Okay, can I, or is...
Yes, please, go ahead.
Sriram, can you mute yourself, please?
Even with the danger that I don't make myself a lot of friends with this question, when I hear these things like that 1/3 of IPv6 does not share the same path like IPv4, and IPv6 is still growing, is there a possibility that we go from 1/3 to 1/2 to even more in the future? And if this is the case, isn't it relatively, how can I say it? Doesn't it make this protocol then, or no, this mechanism a little, or does it make ASPA useless? That's question number one. Question number two is, I never really got all the arguments for moving to AFI agnostic. For me, the main argument always looked like it's easier to implement. It fits well with my implementation. And designing protocols, designing mechanisms based on implementations and how great it is to implement it like this, and it's easier, not so complicated, I think it's a very slippery slope. And every time when I hear that, one word what Job at one point told me, where he spoke about his youth, where he always thought, yeah, this is a great idea, so we have to push it through. And now with age, the understanding that this might have been a bad idea, I have a feeling we go down that route. Maybe I'm wrong, and I know many people don't like to hear what I just said, but I really have the feeling that we see already problems on the horizon, and now we're talking about we have to add it into the security discussion, and that there is a problem you have to be aware of, and maybe one solution by just taking the sentences out to basically, you know what, let's just close our eyes and hope for the best, I think is a really bad approach. Just my 5 cents.
Sriram, you're still in the queue. Did you want to respond? Okay, I guess you're not still in the queue. Job, then Claudio, then Tim.
Thank you. So we have to take into consideration that what we currently see in the default free zone doesn't necessarily logically map to what people will actually use ASPA for. In other words, I do not believe it is wise to extrapolate from what is observable through biased sources like route views into this protocol's design. So an example that is very hard to capture looking at data is a lot of network operators start out their ISP IPv4 only. They connect to a bunch of upstreams and they'd configure an ASPA when it becomes available to them. Now, over time, they notice that the IPv4 price is going up or is higher than IPv6, and they enable IPv6 with one or more of the same transit providers. This usually takes a bit of time. They'll start with one transit provider, then add a second one, maybe some equipment needs upgrading. And the moment they enable the IPv6 sessions alongside the IPv4 sessions, with an API-specific ASPAT model, they would need to go back to the RER-provided web portals and add IPv6 alongside IPv4. In an API-agnostic model, in which we assume that people want to do dual stack over time, this is not necessary as a step. So this is not something that can go wrong or yield surprises. This is the major benefit. And if we follow the argumentation line, I need more granularity, then I would say, why stop at APIs? Why not make it BGP session specific? Why not make it prefix specific? So I would argue the slippery slope is how much granularity do you want to add, and what is the bare minimum of granularity that we can add to move the needle a little bit. And I would argue the current model, API agnostic, is...
Rooter, could you mute?
Sorry, I lost most of a session after talking.
Maybe this is being recorded. So what I'm arguing is that the current proposal is the bare minimum we can do to move the needle a little bit. This will allow us to investigate whether more granularity is warranted in future extensions and what the shape of that granularity should be. Because it's not that API or not API are the only permutations we can look at. It's BGP session specific, even prefix session specific, or even prefix session BGP session specific. Like there's a lot of other options out there. So what we currently have is the bare minimum, and this is the path we should follow because this is what we decided a year ago. Then one point in response to Keir, where Keir expressed concern about new SAFIs coming and clouds starting to rain. The ASPA specification is very specific that it's only IPv4 and IPv6 unicast. That's it. It doesn't do anything else. And that's in both the ASPA verification draft and the ASPA profile draft. So I hope that addresses the concern about the impact of ASPA on future BGP extensions, because we narrowed the scope to just the internet use case.
Can I cut through the mic, Russ, just to reply and then, sorry
Okay.
about that. All right, thank you. Speaking as a working group member again, not as a working group chair. 2 points here. There is a reason why we have AFI-SAFI inside BGP. We started without AFI-SAFI inside BGP in 1994, very quickly realized the need for AFI-SAFI, and we inserted that in 1997. So there are reasons why we do things for what it matters, number one. Number two, Rift and LSVR, as I stated in my comments, carry the same exact V4, V6 routes. It's not like they carry different routes. What you are seeing now is a manifestation where you have a need to carry V4, V6 routes, but using different SAFIs for different reasons. That doesn't need, we need to extend here. I think the draft is very specific, but what needs probably to be looked at is, do we need to yank out AFI-SAFI or do we put it? And if we yank out, maybe some section that describes our justification. So future, if we need to put it back, then at least for the set of folks who will be working in future will know the context. That's all I meant. Yeah, thank you.
So if I may, yeah, can I go?
Yes, please.
Oh, thank you. Sorry, I was muted previously. So I wanted to, I mean, Job already covered some of what I wanted to say quite nicely. I do want to add a couple of things to that. One is that when an AS declares different providers, and even if at a point of time, if one provider is specific to V6 and another provider is specific to V4, in the future, traffic engineering may necessitate that you kind of move some of the V6 traffic to the other provider who is doing V4 currently, or the other way around. So for traffic engineering, that flexibility many operators would like to have, even though they may be having separate providers currently for V4 and V6. So in that sense, it is conservative to include both V4 and V6 providers without the AFI distinction in the ASPA, and so that way, for any kind of traffic engineering which shifts traffic from V4 to V6, V4 provider, which shifts traffic V4 V6 to between the two providers, that will not hinder their operation. In addition to that, the other comment is that by including the V4, V6 providers, both of them without the AFI in the ASPA, the other point is that we would be erring on the safe side, meaning that we may sometimes declare an invalid to be a valid, but it is much more harmful if we ever declare a valid to be invalid. So it is better to be erring on the safe side by having it AFI independent. So those are my 2 points. Thank you.
Claudio, please.
Yeah, I realized that Sriram just more or less mentioned what I wanted at the end. So the thing is that by being AFI agnostic, what we actually do is we actually put paths into a valid state when they would maybe not be valid. But I think it's way more important for operators that this happens than the other way around, where paths that actually should be valid suddenly become invalid because they didn't properly set up their ASPA record. And by that, we're actually making it easier for people to actually start using ASPA. And I think that is one of the more important parts that we need to get right at the beginning.
Go ahead, Rudiger. I think you're muted, Rudiger.
Yeah, well, let's see what failure I run into this time. For Sriram's remarks about traffic engineering, well, if I have actually distinguished between V4 and V6 upstreams, a kind of obviously one would not traffic engineer shifting VX traffic to VY if VY is only set up for VY. That sounds not like a reasonable and expected use case, but anyway, I did not find explanations that when the operator lists single AFI providers in the overall CAS, what happens with the kind of with these additional ASs or paths thereof. There are the remarks, there is the text, you should be correct, and you should be aware of the implications. Please explain. Thanks.
Go ahead, Job.
As I mentioned before, we can add an appendix to be explicit what implications we are referencing. So for instance, the on the side of caution rather than the opposite is something I think we can articulate in a diagram. So the to-do item still stands, and I hope we can provide some text in the coming weeks.
Okay, queue's empty. I think we should move to the other ASPA slides that Job provided. We've spent 40 minutes on this topic, and I think we really need to pick up the pace if we're going to not find ourselves in the same situation where we still didn't get through all the material. Thank you.
Job, do you want to present your own slides, or do you want me to?
Yeah, if you can put them up. Let's start with same origin or whatever you're gonna put up. Okay, profile. Quick update on ASPA profile. Yesterday I uploaded version 18. Next slide, please. This is the overview of the current ASPA profile. This has been implemented by a good number and diverse set of implementers in various programming languages, and I think this profile is stable. We've not seen changes to it in multiple months. Next slide, please. The biggest difference, or maybe the only difference, between version 17 and version 18 of this draft is that we added a note and recommend RPKI validator implementers to be aware of a potential for DOS attacks using ASPA objects. The ASN1 profile does not impose a limit on the number of provider ASNs that can be listed for a given customer ASID. So according to the ASN1 profile, it's possible to list 1 million providers. But if you list 1 million providers, we'd run into issues. So for instance, in the RTR RFC 8210 bis document, there is a 16-bit field for the count of provider ASNs. And obviously you cannot fit 1 million into that range. But the reason we didn't put a limit in the ASN1 profile itself is that you could also create multiple ASPA objects, and they have to be merged by the validator that sees the multiple objects, which would sort of nullify putting the restriction in the ASN1 profile profile itself. So the suggested text is that validators collate all ASPA objects for a given customer ASID, impose a reasonable limit, somewhere between 4,000 and 10,000 seems reasonable to me, and are also conscious that existing RPKI validator implementations, for instance, impose file size limits. Now, in RPKI client 9.1, we implemented a 10,000 provider AS limit. And I think this is something we need to sort of monitor over time, like how does this, is this good or should it be adjusted? So this is why I do not suggest to put in like a strict limit because the size and shape of the default free zone changes over time. But people should be conscious should make some kind of limit. As to what the maximum number of transit providers currently in use for a single ASN could be, there's one CDN that I estimate has 300 transit providers. So that ASPA object would have 300 provider ASNs listed. And that's well below the limit of 10,000 that we imposed. So I think this type of limit is not controversial, but maybe the text is not worded in an ideal way. So if you take a look at that diff and are like, hey, you should phrase it like this, or maybe upgrade a should to a must or something, I'm all ears. That's it for this topic. Any questions?
Okay, I see Kier, Rudiger, and Sriram.
Can you hear me again?
I can hear you loud and clear.
Sweet. Speaking again as a working group member, one question I have, and it may not belong here. Job, feel free to push it aside. But you're suggesting a limit per provider, if I hear you correctly.
Per customer ASID.
Correct. But as number of providers grow, do you think we need to worry about also pacing the data that goes into RPKI router so that we avoid BGP flaps, particularly because inherently there is no pacing inside protocols as we receive updates? And maybe the answer is, hey, do it at BGP level, which is an implementation dependent thing. Or maybe the answer is introduce some level of pacing in RPKI to router. I just don't know. And that's one of the reasons why I'm asking. In traditional BGP, we have such pacing at a peer level, at a route level, so forth and so on, and hence the question.
So in the RTR design, the cumulative validated outcome of one or more ASPA objects for a specific customer ASID have to be packed into a single PDU. So I'm not entirely sure how pacing could be introduced in the current RTR design, but that's a fair question. I think the point is, if you introduce an ASPA object and it contains an obscene amount of provider ASNs, that will potentially cause significant resource consumption on the BGP router side. And the goal of this draft update was to make people cognizant, like, hey, you can put in a crazy number, and maybe we don't want crazy numbers. Maybe we need to cap it to something that is super accommodating to what we know about the current internet, but also is well within tolerance levels of BGP implementations.
Fair enough. That's one point. And the second point is as you said, number of ASs, and imagine where the updates are coming towards a router where, say, number of ASs -1, number of ASs +1, so forth and so on, a continuous update happening, and what it means to CPU on the router side was the second question I had. But if that is something we think is something to watch out for, I think we can put it on a to-do list and then see how we can target that later on, assuming that could be a potential issue.
Sure. Oliver?
Yes, actually, 8210 bis 12 with the 2 bytes, as you said, gives the maximum upper limit, because I can't have 2 PDUs for the same customer AS, because the second one would overwrite the first one.
Right. So the current limit in RTR is 65,535, which I think is unreasonably high, and a few thousand in practice is probably a saner limit.
No, I completely agree with you, but the only comment what I basically, because you mentioned something like one could have a second one, and the second one basically would override the first one anyhow. So there is already a natural limit for the router side that they cannot go beyond 65K anyhow.
Right. And I should clarify a little bit why I put this in the profile draft, because RTR is not the only way to populate data in BGP routers. RTR is one mechanism to transport from cache to BGP router. But for instance, RPKI clients in conjunction with OpenBGPD use a mechanism via the file system, and there no such limit of 65,000 exists. Hence, also having a limit in the validators, what they emit, whether it's RTR or JSON or CSV or OpenBGPD format or BERT format, to me makes sense. So if we lower the limit in RTR, it doesn't lower the limit in the whole ecosystem as it's currently deployed.
Then maybe for compatibility reasons, it would make sense to put into the profile a max limit that does not exceed the RTR. Because otherwise we have multiple mechanisms, and I cannot say for sure that everything gets transmitted because maybe one can, the other can't. So it would make sense then to really have an upper limit putting into the profile.
The challenge though with putting a limit in the profile is that a customer ASID holder can issue multiple ASPA objects that would be merged in the validator. So limiting, putting a limit for a single object would still allow people to introduce multiple objects to get beyond that limit. So this is why I think we have to describe the concept of a limit on the validated payload output side.
Okay, that sounds good.
Okay, Rudiger, then Sriram. Rudiger, you're still in the queue. Did you want to be?
Sorry, I missed the mic button.
Okay.
Okay, I'd suggest to consider putting a note into the draft that suggests that validators actually should have configurable limits and issue warnings if the validated complete ASPA goes beyond the configured limit. Seems to me much more valuable than setting some fixed limit. And a kind of next level question would be if an operator sees that for some AS an obscene number of provider ASs is listed, can we explain how bad the consequences are for the if that operator just configures that this AS will not be allowed to install the ASPA?
In terms of whether it should be configurable or not, that might be more of a matter of local implementation policy.
Sure.
The current text says something like, if this threshold is exceeded, relying party implementations should treat all ASPA objects related to the customer ASID as invalid, e.g. not emit a partial list of provider ASNs. Additionally, an error should be logged in the local system indicating the customer ASID for which the threshold was exceeded. So yeah, logging errors is important, is part of the text, but most important, I think we should really avoid emitting partially complete lists, because I think a partial list is more harmful than no list.
Agreed.
Sriram?
Yeah, just a logistics question regarding the time. So logically, like if we stay on the ASPA topic and move to the ASPA verification, if we do that, I just want to know from Job how much time he needs for his other presentation.
Well, let's do them in order because I think we have them in priority order in terms of time people did not get at previous sessions. And we have another 35 minutes left in this meeting.
Shall we go to the next topic?
We can, which would be SIDROPS verification deck.
Shriram, if you want to do the slides yourself, I can stop sharing and you can share.
You can do it. It's fine. So we don't have a problem. So, you still give me an idea how much is there? Is there only one more presentation after mine? Is that Jobs? Can you give me an idea how much time we need for that?
2 more. So if you can keep it to like 10 minutes.
Oh, you need, okay. Yeah, 10 minutes would be short. Let me, I mean, it may need a little bit more than that, but I'll do my best to stick around that time. So, so this is, I mean, we've been working hard on the verification draft update over the last few months. Of course, through last year, if I may just quickly recapitulate, in March, April of last year, we had an extensive working group last call on the verification draft. Nearly 30 people participated, a lot of good discussion, and all of the comments were satisfied at that time, also subsequently. I mean, there were no objections. There was a lot of support and very good interest in this verification draft. So then in November, I mean, for some reason or the other, the working group last call didn't get closed. In November, some new comments started to come at the Prague IETF. Some of them we heard from Rudiger, and Matthias and Tassilo is on the call, I think. They had some comments to improve the writing of the algorithms, making them more clear. So better understand how valid, invalid, and unknown are determined, a rationale for separate upstream, downstream algorithms, things like that. So we've been working on that, and that's there in the updated version that is on GitHub. Next slide, please. So Rudiger already spoke about this. So in response to Rudiger's comments regarding the consideration, regarding the security consideration section, we previously had one type of shortcoming that was explained, and the rest was kind of hand waving. But now we have 3 types of shortcomings that are explained in detail, and I'll talk about that later if we have time. And these are, I think, the 3 types that we should be concerned about. ASPA is promising us to solve the route leaks problem, which it does very well. But path manipulations is a different ballgame. BGPsec needs to step in for that. So we'll look at that later. But just to be honest and accommodative of Rudiger's criticism, comments on this section, it has been expanded with more details with the different types of shortcomings that are possible. Mutual transit and complex peering. So we had a good discussion in email with the authors. Claudio, Alexander, all participated. Claudio requested that we should make it clear if we are defining like roles additionally for mutual transit and complex, which do not exist in the BGP roles and the OTC RFC. But then we discussed it and we came to the conclusion that we wouldn't bother about like defining those roles and updating the other RFC. Instead, here we would just stick with the term BGP session types and that is adequate. Claudio can speak to that more, but we would just add these mutual transit and complex session types, and that seems like is adequate from the implementation point of view for Claudio and others. We can also talk about this in some more detail later. Next slide, please. So over the next, I should step back and say that back in 2021, we found a bug in the existing algorithm at that time in ASPA verification. Myself, Jacob Heitz from Cisco got involved, and we made a presentation about correcting that bug. So that bug is overcome quite some time back, of course. But anyways, starting from that, the ASPA algorithm is in a correct and good shape. Only question is, are we describing it adequately, like sufficiently for everybody to be able to understand it clearly? And during the working group last call last year, most people seem to be on board with it, and they approved the draft at that time. There was a lot of discussion, and we continuously made improvements in the draft write-up with regard to the algorithms as well as other sections. So at this point of time, we have all the right material for the algorithm. There's just a question about, do we need this detail? I mean, we have the detail, so we can keep that detail, and hopefully everybody will be satisfied, including Tassilo and Matthias, who most recently raised a question about that. And the only other choice is to condense it. Alexander is on the side of condensing it. So it seems that the working group feeling during the working group last call discussions last year was that don't need to be so parsimonious with your words. Explain it clearly and better, and go with it. So I'm thinking that is still true. So I need to be strategizing here properly to keep a track of time. So I have a bunch of slides. So we defined the hop check function. Next slide, please. The hop check, we make use of the hop check function to use the ASPA to determine for each hop in the AS path whether the next AS in the path is a provider or not. We can lay down the path in this form here. The prefix originates on the right and goes through AS1 through ASN sequentially, and these are unique ASs in the path. AS1 is the origin, and ASN is the last AS in the AS path, closest to the verifying or receiving AS. Next slide, please. The key to detecting an invalid is that there should be two hops in this path, and these two hops are facing each other, facing towards each other. For example, from ASI to ASI plus 1, and on the left from ASJ to ASJ minus 1. So facing in the opposite direction. And these two hops should be determined as not provider by the ASPA. And if that is the case, we would have a route leak. So that's the basic definition of a route leak. If an update was received from a transit provider or a lateral peer, it should not be sent to another transit provider or lateral peer. So that's what this picture captures. This is the basic definition of what an invalid is. And this is how ASPA detects an invalid. It looks for two hops facing each other, and the ASPA tells us that these two hops are not provider facing each other. And that's the basic methodology for determining a route leak. Next slide, please. So we have what I just talked about. We have described that with that figure in the draft on GitHub quite carefully. So Tassilo and others can read it and let us know if that adequately meets what you were requesting. So in the case of upstream path verification, we already know that the upstream is applied. Upstream path verification is applied when the update is received from a customer or a lateral peer. And in that case, we already know that the extreme hop on the left is already a NOT provider. And therefore, we just need to look for one single NOT provider in the direction of the flow of the update, and that would establish that the route is invalid in general. So for upstream, there is the simplicity that you just need to look at the path and think of it as going only up, up, up before it is received by the verifying AS. And if there is one single NOT provider, ASI says ASI plus 1 is not my provider, then that is enough to declare the path invalid. So that's the simplification with upstream. And Tassilo asked, why do you separate upstream and downstream verification? So this is the answer to that. Next slide, please. Again, when it is valid, we already know that the hop from ASN to the verifying AS is a customer to provider or lateral peer. So we only need to check the whole path to make sure that there isn't any NOT provider hop. And that again simplifies the upstream algorithm for valid determination. And next slide, please. So unknown is when it is neither valid or invalid according to the previous slides. Next slide, please. So for the downstream, it is different. The first hop is AS, the hop from the verifying AS to the most recent AS on the left side. That is a downstream. So that doesn't play a role in determining invalid. So we look for two NPs within the path from the path that is given to us in the BGP update. And again, if there are two NOT provider hops facing each other, then it is invalid. So in this sense, the downstream algorithm is different. The upstream algorithm was simplified, but the downstream algorithm needs to find two hops facing each other that are not provider. Then we call it invalid. Next slide, please. So I think many people know this well. For the downstream path verification, we have a up ramp on the left and a down ramp on the left, and the up ramp on the right, down ramp on the left. And it should form an inverted V structure based on the ASPAs. So we have ASPA validated up, 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 provider, provider, provider attestations on the right in the up ramp. Similarly, up, up, up on the left side in the down ramp, up, up, up. Each of the hops is attested provider by the ASPA. Only one hop at the top, we don't need to know it. It's allowed in BGP to go one hop across on a lateral peer, and the downstream path would be still valid. So this is how we determine valid for the downstream. And in the downstream, if it's not invalid according to the previous slide, and if it is not valid according to this slide, then the next slide, then it basically is unknown. Next slide, please. So we discussed between Claudio, myself, Alexander, and the rest of the authors, we discussed this carefully. Mutual transit relationship, we required that they should register each other in the ASPA as providers, and we recognize in the latest draft that the RFC 9234, which is about BGP roles and OTC. Those procedures are recommended to complement the ASPA-based path verification. If the procedures, those procedures must not be applied on a mutual transit relationship. So again, this is explained in the draft, updated draft version. Next slide. Then we go to complex next. So with complex, you have an AS can have another AS as a transit provider for some prefixes and as a lateral peer for other prefixes. So what we have recommended is that if any of these relationship, if you have the other AS as a provider, then you should include the other AS as in the ASPA. Even though there is another peering session on which it is not a provider, that shouldn't matter. If on one peering session it is a provider, then go ahead and include the neighbor AS in your ASPA. By doing this, what happens is that we are on the safe side. Sometimes the update may be invalid, but we would call it valid. For example, when it traveled on the lateral peer hop and then was received by another provider AS3 upstream, it would be invalid, but we would call it valid. That is erring on the safe side. But when it is valid, we would never call it invalid. So that is more important. Next slide, please. So let me at this point, keeping time in mind, keep jumping. Like, I can do this presentation in Vancouver for the benefit of for the whole working group. So people can look at these slides and they would not have any, I mean, many of their questions would be answered. So let's skip some slides. Skip this one. Skip this one. So regarding, yeah, just one quick comment. Where we say that the RFC 9234 OTC procedure should not be performed on the mutual transit. Keep whatever existing OTC there is only to customer attribute. Keep whatever exists when you have a mutual transit relationship, like between AS2 and AS3. But don't do any adding of the OTC, etc. On this hop. So that is important for mutual transit, and I can explain. I mean, the slide explains, and I can also explain it in Vancouver, hopefully. Next slide. We can jump ahead. One more. Yeah, now Rudiger's. Next slide. So this is already in the version 17. So this shortcoming of the ASPA verification is already described in the version 17 itself. So this is still included. Here, basically, any AS that is in the downstream path can lie to its customer, and it can shorten the path, and the top hop at the apex of the vertical, like inverted V. It can lie about about that hop at the apex, even though it doesn't have a connection to 2 or 3. It can pretend it has and shorten the path. So this is one limitation of ASPA. It can a provider can fool its customer by offering lower paths with lower length. So that's one shortcoming. Next one. Next slide. So when a malicious removal or addition of AS prepends is possible, and ASPA cannot detect that, BGP-SEC can. Next slide. So there's another, stay there, previous. There's another way the provider can also lie in the upstream direction. But this attack may be too devious, considering that it has to be at least a tier 2 ISP that has to be engaging in this kind of deceit. So anyway, we described it. So now we have these 3, and I think by and large these are the 3 types of shortcomings. Rudiger, I'll make it available to you. The text file, you can look at that. Next slide. So there are 2 versions on the GitHub. We are in the process of trying to discuss and converge. Pull request 24 is something that Claudio, Alexander, myself discussed extensively, and it was made available on May 12. Alexander prefers to be brief on, to be sort of concise. And June 14, he published a master in which many of the things from the PR24 are not included. which in the process I'm a little bit afraid of we may be losing the working group last call comment effects from last year. So we need some help from a few other people to look at these two and compare and review them and compare and let us know and help with the final convergence. So please, thank you. Next one. So for the questions for the working group for the working group folks is the working group okay with a more detailed explanations about how the algorithms work? Working group okay with more detailed explanation, illustration of the types of path manipulation ASPA cannot detect per Rudiger's request. So this is another place where Alexander chose to eliminate much of the additional details and the presentation of the shortcomings. But I think working group perhaps would benefit by keeping that. Then we want to define in the complex as separate types of sessions. Alexander again has leaned towards making like complex one type of session and put the mutual transit under that as a special case. But in reality, I think Claudio was requesting that we just separate them and call them two different types of sessions. That makes it easier for the implementation. Then the fourth dot valid. We have a terminology VAP, validated ASPA payload provider plus. Alexander again, I mean, those are like well understood by the working group. They were very helpful during last year's working group last call. So there's no point in changing that terminology at that time. At this time, Alexander is again leaning towards like introducing new terminology here. And finally, the early adoption benefits has been moved to appendix, but I would prefer to keep it. That discussion was very interesting to the working group. I would prefer to keep it in the main body of the draft rather than move it to the appendix. So with that, I would stop and let people ask questions if we have time.
Claudio.
Just from my side, since my name was mentioned a few times, for me the important part is that the algorithm in itself has been stable for more than a year. So at least we're now talking mostly about how to properly document it and should it be terse or should it be more explained or things like that. And in the end, I don't really care which one we take as long as we finally get to kind of the last call and make it a standard. A lot of the extra explanations could go into an appendix if that helps to make the ASPA draft to actually go forward, in my opinion. So whatever it takes, I think we're at the point where we're just talking about different colors for the bike shed, but the bike shed actually stands already. So we should be able to get this out soon, I hope.
Claudio, yes, good point. Just take a look at, I mean, it would help if like Tassilo had a lot of questions about this and Matthias. It would be good to just for them to quickly look at the two versions. And it's not a whole lot more, maybe a page extra. So we can move it to appendix if people prefer that, but leaving it where it is maybe like coherent for the reader. So Tassilo, Matthias, or others can take a look and offer their comments as well.
Yeah, maybe. I think they're so as said, basically the meat doesn't change. The question is how to present it, and I think there's two distinct problems here. The first problem being, or two different audiences that we want to explain the algorithm to. Or it's one audience, but there's two goals. And the first one is give them an easy to implement version. And the other one is give them an intuition on why this implementation is correct. And that was when we built the ASPA support and RTR-lib. That was the really confusing part, because we had something that was implementable, but we really didn't understand what was happening and why some choices were made. And I think personally, I would split this algorithm section into two things. One, implementation, and one, those, I think, what we called semantics of valid, invalid, and unknown. And yeah, that's my take. And we really should basically sit down, and right now there are those two diverging versions of the document. One goes into what Sriram says, where we explained it in all detail, and the one version from Alexander, where he basically had an implementer-oriented document, which was really easy to implement, but is also, as a newcomer, probably it's very hard to understand. And we really should sit down, maybe ask 4 or 5 people in one meeting, and pick and choose from the different documents which parts are actually good and relevant.
So in response to your comments, we separated the basic principles in section 7.1. So that is where you will find the explanations. And then 7.2 and 7.3 in PR 24 are like clear implementer-oriented description. Thanks.
Okay, so the queue is empty. Let's move to the RRDP, same origin policy.
Before we move there, Russ, note to
Yeah.
chairs, did we do the last call with IDR on that document?
On the RRDP document?
No, the one before, the verification.
I believe that we were waiting for the ASPA profile to finish, because the ASPA verification, right, depends on it.
Yeah, so just a note between the chairs that we should probably cross-reference that.
Indeed.
Or call a call across IDR as well.
All right. Go ahead, Job.
Yeah, I think it would be really good to loop IDR in, but I would wait a little bit, not just for profile. I think that one is slightly less interesting to IDR, but for the verification draft to mature a little bit further.
Yeah. My comments were specifically to verification draft, but that was more about a note to chairs.
May I quickly interject? So should we target for uploading? It looks difficult at this point, uploading by the deadline for IETF 120, which is in 10 days. So is maybe people are okay if we take a little bit more time and maybe upload it just before the IETF starts.
Minimally, we should consider presenting it so that at least the IDR audience is aware of it.
Oh, I'll be happy to present it to a joint session or both in IDR and SIDROPS if needed.
Sorry, Russ. That was all.
Go ahead, Job.
Now, Job, before you go ahead, can I interject?
Sure.
Yep. This draft is currently going through a working group last call. Post last call, we want to accelerate this draft towards the publication. Of course, there are other drafts I think I recall in post working group or last call also. But considering that we're going to accelerate it, we just want to know, I mean, it's pretty harmless. It's non-controversial. It's needed. And it's simple enough that we would like to push it. The chairs would like to push it. So if anybody has a concern, feel free to air it here or on the mailing list. That's all I had. Over to you.
All right. Same origin for the RPKI RDP. Are you putting up my slides, Chris?
I believe they are. It's these, right? Same origin.
I see them.
Oh, my apologies. If I have the chat box open, it won't show me the slides. All right. The problem in RDP version 1 is that the data structures, the XML, allow referencing resources such as deltas or snapshots across different origins. So stuff hosted on different FQDNs than the notification file is hosted. This property can cause a tiny publication point to increase resource consumption on other people's publication points. So for instance, from my tiny experimental publication point, I could reference RIPE-NCC's giant snapshot, which is, I don't know, like 120 megabytes. And in doing so, I would increase the load on RIPE-NCC servers, but also increase load on all relying parties that use the TAL that through which my publication point ultimately is reached. So this is a bit of a simple DOS factor. Next slide, please. The solution is what is called a so-called same origin policy. This is a concept from the web world, and it's well understood there. Cross-origin problems are also better understood in the web browser world than I think they initially were in the design of RDP. And the mechanism forbids you from following a reference to a resource when it's hosted on a different FQDN, and forbids you from following HTTP redirects to resources hosted on different FQDNs. So this means that whoever is hosting the notification file also has to host the snapshots and deltas on the same FQDN. And the implication is that people have to host their own data, and in doing so, bear the cost of whatever they produced in RDP themselves, rather than cheaply referencing someone else's RDP resources. Prior to submitting this internet draft, we had a discussion amongst RPKI client, Routinator, RPKI Prover, and fork development teams, and we were all in agreement that this is a reasonable, easy solution. I think the current status is that RPKI client and Routinator have released an official release in the last few days that implements same origin policy for RDP, and I assume RPKI Prover and Forked will follow in the coming weeks. Next slide, please. In terms of impact of this solution, to me it seemed easier to digest that 4 or 5 implementation teams have to add an extra check to when parsing RDP data, instead of, so an alternative solution could have been to change the RDP protocol to use relative URLs instead of absolute URLs, but that would require the cooperation of all publication point operators currently deployed. That's like 70 parties or so, and collaboration and coordination with relying parties. So that would be so much more work than imposing a same origin policy. This fix is incrementally deployable. Operators upgrade their relying party instances at their own leisure. It's backwards compatible in the sense that none of the publication point operators rely on cross-origin hosted resources. So everybody that currently has something deployed in the RPKI reachable through the 5 RER trust anchors is already compliant with this draft today. And as more and more RPs upgrade to versions that impose same origin policy, the risk will subside. Last slide, please. Currently, we are in working group. Last call. This closes July 1st. There was a lot of support, like a lot of people that said, "Hey, this seems reasonable. Let's go." Alberto was one of the people that had more substantial comments, and he pointed out that my attempt to describe how exactly you would take advantage of the absolute URLs and cross origin references, it was convoluted. That's I guess my summary. So I removed how to exploit it, and this change was confirmed to be beneficial by Fielbuller and Tiestekock. If there are any more comments or things you'd like me to restructure or rewrite, I'm all ears. Your feedback is most appreciated.
So at this point, we're going to have to stop. We're already 1 minute over. I know we have one more set of slides, but I think we made progress, and we will carry that over to the Vancouver agenda.
So Russ, I think
Yep.
Randy had one comment. I'm super eager to hear it. So maybe another 30 seconds.
Go ahead, Randy.
Documenting the threat that this is meant to ameliorate would be good.
So the current document says cross-origin references could increase loads on third parties, but it doesn't go into detail how exactly that works.
I read the
Did
document.
you read it? Okay. So you'd like a little bit more detail added back in?
See you in Vancouver.
See you in Vancouver. Sounds good.
All right. Thank you so much. And thank you to the note taker. Take care.